Good morning, children. So, we have completed our fourth chapter. So, we will revise this chapter. So, we are planning to do the revision of the fourth chapter, structure of the atom. What all things we have learned in this chapter? We have learned different atomic structures, valency, then atomic number, mass number, then isotopes, isobars and isotopes. So we'll briefly revise this chapter. Okay, we'll start. So we know this is the structure of atom. And first we have start. Atoms are made up of charged particles. What are the charged particles? Atoms consist of three charged particles. What are they? Protons, which having positive charge. Electrons negatively charged. Neutrons have no charge. So what are the particles of atom or matter? Protons, neutrons and electrons. Every matter is made up of these three particles. And how the discovery is happened? Discovery of these subatomic particles? It's by J.J. Thomson discovered presence of negatively charged particles called electrons. J.J. Thomson identify electrons. Then Rutherford identify protons. Then Chadwick identified neutrons. The first model is structure of an atom. First model given by Thomson. What is the other name of Thomson model? Do you remember it? Yes, the Thomson model is also known as plum pudding model. Why it is known as plum pudding model? What will the another name? Watermelon model. Why it is known as watermelon model? Why? Because if you take the atom, electrons are scattered like the resins. That's why his model also known as plum pudding model or watermelon model. What are his identification? He said that an atom consists of positively charged sphere and the electrons are embedded in it. The atom is consist of positively charged sphere, electrons are embedded in it. And the number of positive charge and negative charge are equal. So this is the Thomson model of atom. The next one, Rutherford's model of an atom. What is the other name of Rutherford's model of atom, children? It is solar system model. And how he identified this model? By one famous experiment. What was that? Alpha scattering experiment or gold foil experiment. I hope you remember this gold foil experiment. And what are his observation? There are four observations. What are they? Most of alpha particles are undeflected. A few alpha particles are slightly deflected. A few alpha particles were bounced back. So what is model? He said that most of the space inside an atom is empty. Why? Because most of the particles are moved without any deviation. So most of the parts will be empty. An atom having very small nucleus. And the nucleus is very small compared to the size of the atom. And nucleus is positively charged. These are the conclusions. And what is the Rutherford model of an atom? He said that an atom has a positively charged nucleus at its center and most of the mass of the atom is in the nucleus. And electrons are revolved around the nucleus in different orbits. The size of the nucleus is very small compared to the size of the atom. This is the Rutherford model of atom. So, electrons are revolving around the nucleus in through orbits. Like planets are revolving around the sun. That's why this model is known as solar system model. What are the demerits? Demerits, he could not explain the stability of atom. That was the major defect. The next model is Bohr model of atom, Bohr's model. What are the postulates of Bohr's model? An atom has a positively charged nucleus at its center. Most of the mass of the atom is there in this nucleus. Electrons are revolved around the nucleus. These orbits are known as discrete orbits. They are named as K, L, M, N. Number is 1, 2, 3, 4. Electrons are not radiating energy while revolving around the nucleus. Then how electrons are distributed in each shell? This distribution of electrons are known as electronic configuration. What is general formula to identify electronic configuration? That is 2n square. Here n is the number of the shell. That is for K shell that is 1, L shell that is 2, M shell that is 3. So we will calculate. The general formula is 2n square. So for K shell 2 in 1 square that is 2. In L shell n is equal to 2. We substitute, we will get these values. The maximum number of electrons that can be filled in the outermost shell is 8. So here you can see the atomic structure. This method we have seen already. And valency. Valency is the combining capacity of an atom. It's not the same as the number of valence electron. How much electrons required or donate to attain 8 electrons, that is known as valency. Then atomic number and mass number. Atomic number is denoted by the letter Z. Atomic number is either number of protons or number of electrons. Mass number. Mass number is denoted by the letter A. Mass number is the sum of the number of protons and neutrons. The next one is isotopes. What are isotopes, children? Isotopes are the substance which having same atomic number but different mass numbers. Here you can see the examples of hydrogen. So what is isobars? Isomers are the substance or are different elements which having same mass number. What is isotones? Isotones are the substance which having same number of neutron. So these all things we have studied in this chapter. Okay. So you read the textbook and do the exercise. Complete the notes. Okay. Thank you, children.